Welcome to the Pati demonstration of IoT energy meter monitoring and controlling through the Blynk application. So in this version we have added the extra voltage sensor also. With the help of voltage sensor we are going to measure the how much of voltage is given as input to this energy meter, means to the load, and the current sensor which we present inside this energy meter which can measure the wattage, and that will be plotted and displayed on this Blynk application in terms of kWh, and the same will be displayed on the LCD screen. So we can control the devices from the Blynk application. So the Blynk application can be accessed from anywhere in the world. So the main thing is we need to provide the hotspot and data at the kit section. So coming to the flow of the power, so we are providing 230 volts AC inputs to this energy meter and parallelly to the transformer. So why? Because we need to measure the AC voltage, we need to step down that, as the controller can't measure the AC voltage directly. So for that purpose the 230 volts AC will be stepped down to 12 volts AC, but AC also can't measure by the microcontroller. Then we need to convert that to the DC. So with the help of this regulated power supply board, so we are going to convert that AC to pulsating DC, and the pulses will be removed with the help of this capacitor. So after that we will get the DC pure without any ripples. So that will be the around 12 volts. So controller can't measure the 12 volts. For that purpose again we need to do the potential divider voltage conversion. So here using 10:1. For example, if the controller getting 1 volt after this potential divider, so it will taking as 11 volts, as we are doing the 10:1 ratio. So in that manner, if I am getting 12 volts from this one, consider the 230 volts AC is the input, as this is the step down transformer of 230 volts AC to 12 volts of AC. So in this manner we are going to measuring the input voltage by using Arduino from A0 pin. And coming to this power consumption of the current rating, so this is the input to this current sensor which is there inside this meter circuit, and in series we are providing that to the load through the electromagnetic relay, means 230 volts AC to the relay through the CT, means the CT should be connected in series. Then only we can measure the wattage of the load which was connected in series to the CT. So this is like 230 volts 200 watts. So why I'm using this 200 watts, nothing but we can use 100 watts also, but the power increase in the power consumption is the slow rating. That's why to make that as a faster rating manner we are going to use of 230 volts 200 watts, and that will be controlled through the electromagnetic relay which was connected to the Arduino Uno board at 10th pin. And then next, this is the same step down regulated power supply board which will take 230 volts AC inputs and provide as a 5 volts DC constant output. So that is the main operating voltage. 5 volt is the main operating voltage throughout this input and output modules. The so-called status of the power consumption in kWh and voltage will be displayed on the 16:2 LCD screen directly, which we have interfaced at the 15, 16, 17, 18, 19 and the third pin of our Uno board. So the Wi-Fi module will send the data to the Blynk application and will read the data from the Blynk application and control the relay which was connected at the pin number 0 and 1. So one more IC is there, that is the PC817, which is the main isolation between the current transformer, the current circuits inside the energy meter and our Uno board. So here when we are measuring the pulses from this current circuit one, if we provide that directly to the Uno board, the Uno board may get damaged. So in order to protect that, we place the PC817 optically coupled one. So if is there any high short circuit occurred inside this, only the IC will get damaged, so that we can secure our whole main motherboard circuit. So that purpose we are making use of this PC817 optocoupler. So let us see the demonstration. Before on the kits, we need to enable the hotspot in your mobile phone and change the hotspot name to project 5823 and the password should be 129. So 123456789 and AP band should be 2.4 gigahertz. So after that, on the hotspot on and the data. And now go to the Blynk application. Download the Blynk IoT application from the Play Store directly. So now it is showing the offline, means the device is offline, there is no online, because there is no switching power supply or no internet power service connection to that. So now on the power supply to this system, and now we can see the welcome message on the LCD screen, and then after the voltage continuously measured by our system and displayed on the LCD, slowly the voltage will be increases. And now, so right, the device is online now, we can see that. So we are getting the voltage here. Right. Okay. So now the voltage will be displayed on the Blynk application directly. Just log into the Blynk application. Now click on this. So we can check the readings directly on this one. Right. Okay. So if you want to control the device, these fluctuations occurred based on the net speed only. So now I want to on the device. You can reset the system. If you want to reset, just this is the on off switch. So means reset the Arduino board. This is the switch. Okay. So just we can reset the controller so that the fluctuations will be isolated. And now if you want to on this relay, just on that. So now the voltage and the current in wattage hour will be displayed over here. So we can see that. So 0.003. Right. Okay. So we can control the bulb from anywhere in the world directly just by switch off the power supply. So if the more fluctuations occur, just we need to reset this board. Right. Okay. To be displayed. So the system continuously send the data to the Blynk application and just on the bulb and off the bulb. So this can be accessed from anywhere in the world. So in this one we have added the feature like voltage measurements and wattage measurement directly.